Today we're going to talk about real-world data observability and not just theory. We're going to look at it in action. Today I have Ryan with me from Databand and Eric from IBM. They are going to show us real-world scenarios, data observability for Airflow, for Python pipelines, and they're going to show us for dbt. So very interesting today, a practical session. Let's bring in Eric and Ryan. Hey guys.
Hey, what's happening?
Hi.
Hi, great to have you here. Yeah, maybe we do a quick introduction round for everybody who doesn't know you yet, and then we're going to go. Ryan, I think you're going to start off with a few points about why observability and what that is, right?
Yeah, for sure. Yeah. So we've done a few sessions already with you and Andrea. So glad to be back here with the data engineering community. I'm me and Eric both came from Databand, which is an IBM company. Now we were acquired by IBM about a year and a half ago now, coming up on that in July of 2022. And we were acquired to really be the number one choice for customers looking for data observability needs in their environments today. And so we had a lot of customers dealing with a lot of challenges we'll talk about today around data incidents and firefighting data issues. So we'll be able to go through some of those discussions today. And I was in charge of leading all the marketing and go-to-market activities at Databand.
Cool. Yeah, a quick reminder for everybody. In the description below, we put a link to the registration of Databand. So if you want to follow along today and want to explore Databand, you can go there, click the link, do the registration, and then you will get access to I guess a demo environment, right? Or a prepared environment.
Yeah, it'll be the same exact one I'm demoing from. So anything I show today, you'll be able to follow along, and we'll probably leave it up for maybe a week or so after this if you want to poke around and take a look.
Yeah. Eric, quick, a few words about you.
Yeah, hi, I'm Eric Jones. I've been with Databand since September 21. And I was originally the lone solution architect over there, came over to IBM and did a little bit on the sales side, and now I'm part of the product management team. So basically curating our roadmap and hearing feedback from customers and prospects and things like that.
Nice. Thanks. Yeah. Everybody, by the way, I see a lot of people here. If you have any question during this, let's use this opportunity. Put them in the chat. Either we answer directly or then we answer at the end the questions. So use this opportunity. All right, Ryan, do you want to share your screen? And
yeah, man, let's get this going here. I got my screen shared. So
nice.
All right. Yeah. As Andrea said, like if you have any questions, feel free to drop them into the comments area. When Eric's kind of taking over his session, I'll try to answer them in the comments. And then while I'm talking, maybe Eric can help answer some comments as well. But yeah, definitely excited to be here and give you some real world data observability use cases in action. I know Andreas had said that there's a lot of like theory out there and some nice talking heads of how this relates to data quality and more nebulous kind of around how this actually gets implemented. So we're going to give you some real world examples of that today. So talk about why observability kind of matters, what's needed for continuous data observability, and then we're going to follow along with some real world use cases in action with Eric. So let's go ahead and get started. But first, again, quick reminder, Andreas put this into the chat comment section, but please go to this URL if you want to follow along during the hands-on portion with Eric. Just go ahead and do that. Go back to the comments and go ahead and click that link and get going. You can skip over all the boring stuff that I'm going to talk about today if you don't really care what I have to say and you want to get into the technical areas. Just go ahead and register as I'm talking, and we'll get you plugged in. We already mentioned that some of the presenters, me and Eric, dynamic duo, Batman and Robin, as I like to say. You can figure out who's Batman, who's Robin. Maybe it's Batman and Superman. Yeah, I'll take Superman, Eric. But yeah, really excited again. Came over from DataBand back in July of 2022. So excited to be here, part of the IBM community. All right. So what's going on with this whole data observability thing? One thing I'll just say is that data observability is becoming more and more of a C-suite priority. So if people are on the call today, you may be hearing things like data governance, data quality, data reliability, things like that as priorities or governance, things like that for maybe that you're getting pushed down from your chief data officer, your CIO, CTO, VP of engineering, whoever that is. Don't be surprised if data observability starts to become one of those things in that conversation. What we're seeing here from Gartner is the fact that it's becoming more and more within the hype cycle as something to be aware of, and to be more aware when it comes to how data observability fits into your overall data strategy. It's something that is on the minds of a lot of people now because it's getting more and more visibility in the C-suite. So this is just a quick graph of the hype cycle for data analytics and governance from Gartner, and you'll notice data observability right there, right behind AI governance in terms of trigger innovation and the peak of expectations. So definitely, if you're not hearing about it today, definitely keep your eyes open and listen to this conversation we're having, because it may be saying something that could indicate you have an observability problem. And one of the reasons why we know there's an observability problem is because there is a lot of focus on data engineering that's in high demand. This is a report from the State of Cloud Software Spending by Battery Ventures, and you'll notice that back in 2022, the highest priority for CXOs to hire, that was a data engineer. It was even higher than a security engineer and a DevOps engineer, which is very interesting. Wow. And why is that the case? Like, why are we getting so much focus around data engineering being one of the top, if the top priority for CXOs? And I'm sure Andreas loves to hear this because he has a whole course on learning how to be a great data engineer. So I'm sure he likes this this graph here. But why?
I also love the job. So
you love the job too. Yeah, exactly. But no, I mean, so what's spurring this on? Like, what's going on with this high demand? Well, it's pretty simple. It's because you guys have to deal with all this stuff. If you look at what across the ML, artificial intelligence, data landscape, it's pretty massive, from infrastructure to analytics to applications. Like, there's so many different tools and interconnected solutions that data engineering is having to either connect or push data to or use. And they've been told they have to use a certain tool, or maybe a new open source tool pops up and they go, hey, let's use this. It's complicated. And there's a reason why these data engineers, even though they're in such demand and they have such a complex scenario to deal with, there's also a reason why they feel like this a lot of times, which is feeling like they're underwater. I know I saw a quote the other day talking about how I think it was like 80 to 90% of all data workflows go through the data engineering team. And there's a reason why you may feel totally overwhelmed. You're constantly having to firefight data issues, or you're getting asked to ingest more and more data, or you're asking to produce faster, or your data SLAs just got, more and more harder to meet. All these things kind of come together for data engineering teams, and they feel like they're underwater constantly. And what does that kind of look like? Why? And the reason why they're also like that, if you add in all of the tools that are there a part of their ecosystem, then you drop it into this very complex assembly line. The producing of the data gets touched by multiple people at different stages. So from sources all the way to data access, you're dealing with things like orchestration, transformation, developing stuff, testing stuff, deploying stuff. And you're also being interacted with more than just the data engineering team. You're talking with data analysts, analytics engineering, data scientists, architects. All these things kind of come together where this assembly line, if it's all green, everything looks great, that's awesome. But most of the time, it doesn't. Most of the time, the assembly line breaks and it comes out of nowhere. This is a common thing that we also hear, which is like, we had no idea that our pipeline was broken. We had no idea that a data set sent over the wrong schema. There was a schema change. So you kind of get blindsided a lot of times. But you're just trying to move data and get it to where it's in a state of access for whatever project you're working on, whether it's analytics or an ML project or data products, you're just trying to get the data there in a reliable fashion that's also trustworthy. And this kind of hits you. So what areas can things break? They can break at the orchestration level using Airflow possibly. They can break at the DBT level where you're trying to transform something and maybe the test fails or maybe the build job didn't complete. It could happen in a Snowflake table where everything went well, but you passed it over, and in the table itself, the wrong data is there or it's duplicated. Even though the pipelines ran, they were green, everything went well, you delivered the wrong data in terms of accuracy. So all these things kind of happen within here, and we hear this a lot. These are just some quotes we hear from some of our customers. This is a cryptocurrency platform we talked to, and they said, "Hey, we can't afford to wait hours for critical pipelines down. It's in a breach of our data SLAs, right? That's a problem." A 3D design company said that when we present customers with inaccurate information, the results is a lack of trust. A real estate software company said today we need our customers to tell us if our data deliveries are late, and it's extremely frustrating. Talking about how things happen in production, you have no idea that things were late or didn't get it on time, or there was an issue that happened that you wish you would have been alert of way earlier in the process. This is from an investment advisory firm saying that every day our source data has missing or inaccurate values, which can disrupt our machine learning algorithms for stock changes. So a lot of these are all real world quotes we've gotten from our customers and why they started to look for an observability use case possibly. And that's where Databand comes in. What we're trying to do at the end of the day is just help the data platform and engineering team deliver more reliable, trustworthy data. So they're not constantly firefighting issues, not being woken up in the middle of the night for something that really didn't matter, and really help them focus on building versus just maintaining pipelines. And the analogy I like to give, and hopefully this analogy works because I like this show, but I got scolded the other day for not actually watching a full Formula One race. But hey, there's a show called Drive to Survive that's on Netflix. Hopefully people have watched it. I showed this to somebody and they said, "Have you ever seen an actual F1 race?" I'm like, "No, I haven't watched a full F1 race. But I also haven't watched a full NASCAR race either, and I live in the South of the United States of America. So I don't do either of those. But the show was really cool. It's Formula One Drive to Survive show. And what it's all about is these teams, obviously, if you watch Formula One, they're trying to drive their high-performance cars as fast as they can around the track, not crash, and win the race. It's like, yeah, no duh, right? But in the show, you start to see how interconnected everything is. The race car is finely tuned. They talk about the car a lot. They're like, "Oh, the car this year is way better than last year. We did a lot of engineering to it. We fixed it. We changed out the knobs here. We changed the way the engine is, and so on." And then you have the command center, the people that are actually radioing to the driver who's driving this amazing car to say, "Hey, you need to take that turn tighter. You need to speed up. Your tires are about to go out. You need to come in for a pit stop change." And all that stuff is relayed by sensors. So if you think about the part of an F1 car, it's got all of these different sensors around it that are telling the whole crew what's going on as the car is in motion. So if you don't have these sensors, you could be driving the car. It's almost like you're driving it completely blindfolded, because that engine failure that possibly could coming up, or that your engine's going too hot, or possibly coming in for tires like I talked about earlier, if you don't know about those things, you're going to have a rude awakening when your tire blows out, or when your engine fails, or when you have to, your gas is low, right? All these things kind of play into having sensors to alert the whole team around what's going on, so you can make corrections proactively and not have the cause then kind of make you crumble in a state where you can't actually win the race. If you think about what data observability is doing, that's exactly what's going on in a modern data stack architecture. If the car is the modern data stack and the driver is somebody who's using that modern data stack in a right way, well, the engineer or the analytics engineer or the analyst, they need to know about the things going on in the car as it's in motion, as it's going as fast as it can around the track. And that's what data observability is doing. We're looking into things like your Spark processes, your DBT jobs, your Airflow jobs, your Snowflake tables, Python scripts. We're looking at all these things to make sure nothing's going on that could really cripple your data engineering process. And then we alert you immediately when something is going on so you can fix it and be off and running and drive as fast as you can down the track or around the track. That's observability in action. And when you juxtapose this to, well, if you don't have data observability, these are kind of the consequences that you have. You have a lot of times this reactive approach to when things actually occur. So there's a lot of black boxes from sources to your warehouse to your data access. That's why we gave those quotes around people saying, when we get it in our hands, the data in our hands, then we have to alert the data engineering team that it was wrong. That's way too late in the process. So a lot of times when this happens, there's data quality issues that are never discovered. You have teams that are reported by, like the data consumers, like we talked about just now. And then the issues take a long time to fix, from basically take about weeks to actually resolve if they're caught so late in the process. With data observability, again, going to that proactive, more continuous approach with the sensors around the car, if you have sensors within your modern data stack and you're able to detect these things, you can resolve them faster. You can detect them earlier, resolve them faster, and ultimately deliver on your data SLAs. So the reds that you're seeing here, these are all different types of alerts we can have. They're not question marks anymore. They're actually alerts that we set up within DataBand to then alert you around each stage of where the data is moving so that you can resolve it as soon as it happens, versus waiting till the very end, then getting an alert, and then your data is already corrupted by that point. And the way we do this, and Eric will talk kind of more about this when we get into the actual demo, is you think about DataBand, you think about it through kind of three lenses of how we're approaching incidents that occur within your producing the production of the data. So data incident management, that's another way to view what data observability is and how it works. Basically, it's operationalizing the detection of these alerts and then resolving them. So it really comes in three different ways. One is around like the process quality. This is your pipeline stage, your job performances, maybe pipeline latency. This is really geared towards that data platform and data engineering team. It's, hey, how the pipeline's working. Was there a problem with the throughput of the data? All that relates to process quality. The next is really around data quality. And this is the structure of the data. Is the content up to date? Are we sending duplicates over to tables? Is the data getting there in the right time? Is it fresh? Is it not repetitive? These are things that maybe an analytics or science team could care about. Also data engineering team, depending on the size of your team. And then the last one is getting into the context around these process quality and data quality issues, which is really around its impact analysis and data lineage. So it's looking at the relations between the data, the pipelines, and then mapping those to impacts that occur and alerting all the users to say, hey, this is how a process quality impacted a data quality issue, or vice versa. So if you look at through these lenses, we're really looking at process quality, data quality, and impact analysis to tie all this together so you can get the incident management for all these alerts kind of under one roof. And not to belabor the point, but I've always said this about DataBand. Think about it in three ways. It's you're detecting earlier, resolving faster, and delivering trustworthy data. That's what we're doing at the end of the day to help data engineering teams. So before I get to Eric, I just want to quickly highlight a few customers. One's Trax Retail that said that they reduced their data instance down from 60% to 1% by just kind of seeing how DataBand could detect issues and help them fine-tune their ML pipelines. We have a large bank that is observing around 5,000 plus Airflow, Spark, and dbt processes or pipelines right now. They're moving a lot of workloads to the cloud, so they're able to stand it up there. And another one I'll call out is that Global's Bet Sporting Company is monitoring about 90% of their production pipelines with DataBand today. So anytime anything goes wrong in the production, they're ready to be alerted and resolve those things in a matter of minutes versus days. And so what Eric's going to do is, and I'll pass it over to him now, which is he's going to go through some real world use cases using Airflow, using Python, using dbt, and showing how you can detect and resolve issues within DataBand. And you can follow along the way if you want, if you've already gone in and got access to the workshop that we have in the comments, go ahead and go there now. But I'll pass over to Eric as he actually shows off some real world observability in action. So I'm going to pause here.
Thanks, Ryan.
And I'll pass it over.
Before we pass over, I've found it very interesting the view of the hype cycle. I never looked at this from a hype cycle perspective. I immediately would have thought it is more to the right, because tools are already very far, like feature wise, and the need is really there. So why this is so far left on the hype cycle is a bit surprising to me.
Yeah, and it actually jumped really quickly. It was on the hype cycle in the 2022 hype cycle graph. There's a couple other, there's governance, there's cloud, there's a lot of other hype cycles out there. But it was actually lower, and what you're seeing is it's jumped, and that in 1 year it's jumped very quickly, because I think that this is probably one of the hottest topics within the data space now. So it's a fast moving trigger innovation. I'll just say that.
Yeah, the need is there very, very much to do. Yeah, Eric.
Yeah, thanks. Okay, that's what I was about to ask. Yeah, so hi again. I'm Eric Jones. If you've seen the link in the description of this event, we do have an environment available where you can register yourself and kind of follow along as I'm clicking through things, or even after the fact, over the next week or so, just kind of take a look around. I have activated everyone who's registered up until right now. So I'll talk a little bit about the pipelines screen and just like the general concept for a few minutes, and I'll do another check before we get into anything that you might want to follow along with in terms of alerts. But so what we're looking at here in Databand is the pipeline screen, and this is really where you can see all of the jobs that are being monitored by Databand, some information about their last runtime, their states, their any alerts that have triggered over time. Today we'll predominantly be showing examples with Airflow, and within this Airflow example, we're going to have some things like some Python operators kicking off. We're going to have some dbt cloud jobs running, and you'll see how this all kind of comes together. But this pipeline screen will contain all of your source systems, like whatever pipelines those may be, whether it's Airflow DAGs, Azure Data Factory jobs, data stage flows, or it could even be standalone scripts like something from Spark or Python or Scala. So as we drill down, we'll start to see a lower level of info. Here we'll see all of the runs that have been tracked by Databand over time. So this is going to allow you to go back and look at these historical runs. Maybe there's some issue that you've seen before, and you want to go and kind of take a look at those logs from those previous jobs and see, maybe take a look at your notes and see what you did to resolve that. And then lastly, if I drill in to this lowest level, this is where we are looking at an individual run in Databand. So what we've got here on the right, we've got our graphical representation of our pipeline. So if you're familiar with Airflow, this is going to look very similar to what you would see there. But regardless of the pipeline technology you're logging, we'll always show this view here. It's going to look exactly like this. So your stages and your data stage flow will be here. Your steps and your data factory job will be here. So you'll have this same look and feel. Beyond that, we'll have these tabs across the top where you can start to get into a lot of the finer info about the pipeline run that you're looking at. So this could include things like you could click through your tasks and see like any parameters that might have been passed to these tasks. Like in our case, we're looking at parameters passed to Airflow. I can see any logs that have been captured as part of this run. So as I click through these, you'll see the logs come up on the left. So it will filter based on whichever task that I have selected. And one thing I'll point out here is one way that Databand is going to simplify the resolution process is that when you are monitoring multiple systems that we have the ability to integrate with, you will see that we can bring all of those logs together in this central view. So as I said, this is an Airflow DAG, but it is kicking off a dbt cloud job. It's also kicking off some, let me change my view here. It's kicking off some Python scripts, and I can see the logs from those things side by side without jumping around from system to system. So click on this first task. I've got my Airflow logs. I can click on my DBT task. I've got the logs straight from DBT, whether this is DBT Core or DBT Cloud. We can show that here. And then Python, a lot of this will be the Airflow logs again, but if there's anything that was logged by Python as part of the execution of my Python operator, I could see that here. Other use cases where this is really helpful is with things like Spark. So going to ideally prevent jumping back and forth from Databand over to your Spark environment, whether that's Databricks or coming through logs on AWS or whatever it may be.
That was basically always the task, right? For somebody who was done problem solving, always jump to each system and then go through and
Yeah, exactly. And in most of the cases when we're monitoring a pipeline technology like Airflow, it's pretty easy for us to build links back to Airflow as well, or Data Stage or whatever it may be. So the way that this helps is, we hear customers tell us that, we've got our data engineering team that's responsible for multiple clusters or multiple environments, and sometimes they'll see an alert come through and they're not sure, like, where's this one located? Got to go check some file, get the credentials and whatnot. In Databand, we can pretty easily build those links to Airflow from Databand. So like I can easily jump straight from this tag in Databand over here. Now I've got more direct access to this information if I need it, but ideally I won't really need to do that. Just if you need it, it's there. Um, so just drilling down now to the last level is where we'll talk about data interactions. And so what we're doing with data interactions is that in the course of the execution of any pipeline, you're going to be processing data. So common usage patterns are you're ingesting from somewhere, you're doing transformations, you're writing to some staging area, you're loading it to your production tables, whatever that may be. Sometimes it's ELT, sometimes it's ETL. But what Databand is aiming to do is to provide some insight, not just in the overall execution of this pipeline, but we're wanting to provide some visibility on the data itself. And so we have a few ways of doing this. In my example here, this is a Python script that I've monitored. And just to give you a quick idea of what this looks like in the code. So before Databand, I'm working with the Pandas data frame. I've got some Snowflake query that I have sent over to Snowflake. I've loaded that back into a Pandas data frame. But what I want to do now is I want to profile this data set with Databand. And so when it comes to things like Python or PySpark or Java or Scala, we have tools for wrapping around those data frame operations. And here's an example with our Python SDK. We have this function called dataset oplogger. It's going to let me wrap around this data frame and extract a lot of helpful information. So it looks like this is pretty wordy, but you can accomplish this with a single line of code. I just have this for illustration purposes, but with this profiling, you're going to get information back like a preview of your data, the schema of your data, column level statistics, and you can specify certain other things like whether your data set path is partitioned or not. And with other systems like Data Stage, they provide information about the data sets a little more readily, so we don't have to necessarily change the logic of our job. Data Stage automatically provides that to us, and we'll be doing the same thing with Azure Data Factory, which is our newer integration. So jumping back over to data interactions, and 1 second, I'm going to check our user registration real quick. Okay, got 3 new people activating you right now. Okay, everybody that registered since that last check-in, you should be able to log in now with the credentials that you selected when you registered.
Cool, thanks, Eric.
So here, what we're looking at is a particular data set operation, and everything, all data sets in Databand are looked at in the context of an operation, so either a read or a write. In our case, we can see at this top level pretty much the minimum amount of metadata that we would show about any data set operation, and that's going to be the path of the data set. So this could be a data lake path, it could be a data warehouse table URI, it could be like an HTTP endpoint, whatever it may be. You can see that here, and this is going to be important because it becomes the basis for our lineage that we build a little bit down the line, which you'll see some examples of. And then over here, of course, we've got the shape of the data frame. So number of columns, number of records. We can see that record count over time over the last 15 or so runs. Just do a quick sanity check to see if this value makes sense. And of course, if I wanted to, I could enable alerting on this record count. Like I could do anomaly detection, or I could set some threshold saying, tell me if it's greater than 20,000 records, or tell me if it's equal to 0 records. There's lots of different ways you could set that alert up, and we'll talk a little bit more about that shortly. If I click in here, I've got the actual preview from my data. So by default, I think it's, I want to say if you enable previews, it's grabbing maybe like 8 kilobytes of data or something like that. I will say that previews are off by default. You would have to explicitly enable these. So don't think that, all of your PII is going to just leak into Databand just from simply logging this. Like you would have to explicitly turn that on.
I think, Eric, I read
Mhm.
somewhere that this is also can get a performance issue, right?
Previewing data, not really. Column statistics, you could see some impact there, and I'll talk about that
Okay.
under the schema here. So as I drill into my number of columns now, this is where I've got my schema. I can see all my column names and column types, and this is going to enable me to do schema change alerts. And the way our schema change alerts work, and I've got an example I'll show in a bit, but the way that these work is that you don't have to manually keep a list of what the schema for any given data set should be, but rather on any given run of this data set, we look at the preceding run and see if anything's changed since then. So if columns get added or removed, or a data type changes the next time that this runs, I could be alerted on that. And then lastly, if I drill down to this lowest level, this is where I can get into column statistics. So this will be for basically any column, you'll get back info like null counts, null percentages, distinct counts. And then for numeric columns, you'll get back the basic statistical metrics like average, standard deviation, min and max. And as I click through these, you'll see that we've got the history of each of these metrics over the last 15 or 20 runs or so. And you'll notice this green area around our data points here. This represents our expected anomaly range based on historical values. So even though you can enable anomaly alerts within Databand and get pretty specific in terms of what your parameters are, in terms of like number of runs you want to look back, what we're doing by default behind the scenes, like in pretty much any case like this, is we're looking at a rolling window of 10 runs of the given metric. And we're applying basically like a medium level of sensitivity. And so going into each run, we're saying, based on the last 10 runs, we expect this value to be between this max and this min. So everything that falls within the green area is good. Anything that falls outside of it, like this red point here, is bad. That represents an anomaly, and that's something you could potentially alert on. And so with column statistics, this is on the subject of performance impact. This is one of those things where there can be a trade-off. These statistics are calculated at runtime. So when this Python script ran, it calculated these statistics and only sent these aggregate metrics to Databand. You never send your actual complete data to us. It's always just metadata or aggregates like this. So when you're working at the scale of tens or hundreds of millions or billions of records, there can be a trade-off there in terms of it's great to get these column statistics, but I don't want to add 20 minutes to this pipeline if it's a very wide data set. We have tools to get around that. So you can specify as part of that configuration to wrap around the data frame, you can tell it only profile these columns, or profile all columns except for these columns, or only do numeric columns, and so on and so forth. And then when you're talking about Spark specifically, we do have a Spark listener, which can be used to capture high-level info about data set operations without changing your code at all. The trade-off there is you don't get the column statistics, but you still get the record counts and the schemas and the data set paths. So I would say that most of our current customers that are working at that scale of hundreds of millions of records, they tend to use tools like our Spark Listener. So now we'll jump over and spend the rest of our time talking about alerting and doing a quick refresh on users, no new users, okay? So alerting is really the main value prop of Databand. So we've logged a lot of really helpful information, but now we need to get this information out to the people who are responsible for fixing any issues that may arise. And we do that through our alerts. So I won't spend a lot of time here going through all of the available alerts. If you're signed up on the environment, you can kind of click through here and see what the descriptions are. But the idea here is that, number one, you will define an alert, whether that's some pipeline alert, some task level alert, some data set level alert, whatever it may be. You'll then assign your alert definitions to receivers. So a receiver in Databand is the endpoint where your alert information is going to be sent. So if I click on Add Receiver, we'll see here that out of the box, we've got support for Slack, Teams, PagerDuty, and email. I believe soon we're going to be adding a generic webhook option in here as well that will open things up a lot more and allow you to integrate with tools that aren't shown here out of the box. But the idea here is each individual or each team can create their own receivers, and then you can pair your alert definitions with these receivers. So it's not one of those cases where all of the alerts dump in a central location, but rather you can get very specific in terms of, this data source goes to this team, this project goes to this email address or this Slack channel. And so there are some patterns that we see with this. So a typical pattern that we see is things like our critical alerts here, the things that are just absolutely business critical that have to be fixed right away. Customers might send these over to PagerDuty, where somebody's woken up in the middle of the night to come and fix one of these issues. Versus these lower severity alerts, these might go to one of those shared Slack channels, and whoever gets to it first can get to it, but it's not a major deal to respond to that right away. And lastly, I'll just point out that any alert definition can be paired with any number of receivers, and any receiver can be paired with any number of alerts. So you're not limited to, say, just one receiver per alert definition, even though that's probably the most common use case. We do see instances where maybe a managerial type persona might want to create their own personal receiver to their own email, and they might just go through and start to basically, I say subscribe. It's basically like subscribing to alerts so that they can get that personal heads up whenever an issue arises. Checking users again. I have one new user. I just activated you, so you should be able to log in now. All right, so now we'll spend the rest of the time just going through some examples of these alerts. And yeah, I just saw your question. That's about Datadog. That's pretty much how I think Ryan explains it to people, is Databand is like Datadog for data.
For data engineers.
Yeah. We actually see, we've got many cases where we have customers that use Datadog and Databand. So it's an APM tool versus a data observability tool. So kind of like, Datadog might be watching for the memory consumption and CPU consumption of your Spark cluster. Databand is actually reporting on that data that's flowing through the Spark cluster. So they're definitely not mutually exclusive. So we're going to spend the rest of the time just walking through a few key examples of some of the popular alerting that we see in Databand. So first and foremost, the number one alert type that we see by far is going to be pipeline failures. So even though you can set up alerts for any pipeline state, so you could say, tell me when it's successful, or tell me when it's skipped or canceled or whatever, failures are going to be the most common use case. And what you're going to see when you come to these alerts, and I'm just on the general alert screen right now, we'll see this top level of information that's got the basic summary. So what is the type of alert? What is the name of this alert? What was the trigger value? What time did it trigger? What's the project? What's the source? but this is going to be what information goes to those receivers. So like in your email or your Slack channel or what have you. But then as part of that payload, the other thing that you would see would be a link that brings you to the alert details screen. And this is where the research and like the investigation really starts to happen. So I'm looking at a job now that's failed in my Airflow cluster. I've gotten this alert from Databand, and I want to investigate what happened. So at the highest level, of course, I can see the pipeline name. I can see the run name. If I wanted to, I could jump into this run in Databand, and I could use a lot of those tabs that we've shown before. I could also, of course, jump over to this execution in my Airflow cluster if I want to see it there. But we're going to try to stick to Databand if we can. So the first thing with a pipeline failure like this that you're going to want to know is, like, what is my error message, right? Like, what caused the failure? So that's going to be presented up front, nice and neat over here on the right. We're extracting this error message from the source system being monitored, presenting that front and center. And so now anybody who's investigating this issue in Databand, it's pretty simple to see what the issue was. I've got an AWS token that's expired. I know how to correct that. This is actionable info. I really could stop right here if I wanted to, because this is an easy one to solve. We may think that this error message is not helpful enough, so we might want to click over and take a look at the more complete log. So I might be curious to see any warnings or things like that that might have triggered before then. And of course, again, if I jump into this run in Databand, I can see all the logs from every task. But in this case, we're looking at the logs specifically for the task that failed. Over here on the left is where we get into the impact analysis. And this is where we're asking questions about what are the downstream things that are potentially affected by this failure that has happened. And the way that we do that is we infer cases of lineage across your pipelines using your data sets. So if you remember earlier, I talked about the data set path and how that becomes the unique identifier for your data set. So if I come over here to our data set repo, I'll see all the data sets that we've ever logged as part of this environment. I've got this path here, and this is that unique identifier. So Databand has this lineage job that runs every few hours, and what it's doing is it's asking the question for each of these data sets: does this data set have some pipeline that is outputting to this data set path? And then does it have another or multiple other pipelines downstream that are ingesting that, right? So pipeline A produces a file, pipeline B reads that file. When we see that happening, that's when we can infer that there is some dependency between those. And that's what we will start to highlight in this impact analysis screen. So on the one tab, we've got our affected data sets. So these are the data sets that are downstream of where the failure happened. These are things that are potentially at risk or possibly skipped today as a result of this failure. We also have affected pipelines, and this is where we get more into that lineage discussion. So what this is telling me is not that these pipelines have failed, but rather that these pipelines rely in some way on a data set that has been produced by our failed pipeline. So we think that they could be at risk, and you might want to take that into consideration. And then, of course, we have missing operations, and this itself can be a dedicated alert in Databand. But what this means is, over time, by observing this particular pipeline, daily sales ingestion, we've learned that data sets A, B, C, and D are typically produced as part of this pipeline. And so when subsequent runs come and we only see data sets A, B, and C, but not D, we can raise that flag to say, hey, we expected to see D here. You've typically logged it in the past, so we think it's missing. And that's the type of thing you would see here. An easier way to interpret a lot of this is through the lineage tab up here. So we've got two views for this. We have the lineage of the alerted pipeline itself. So this is where we take our basic graph view that we saw back on the run screen, where we've got each of our tasks. But now we bring in the context of data sets. So I can now see the inputs and outputs of each of these. And you'll notice here at the end, we've got this failed task. And after this failed task, we have these three data sets that are highlighted in red. And what this is telling me is that we know from observing this pipeline that this extract regional sales task typically produces these 3 CSV files, but because it failed today, we didn't see these, so we think that's a problem. We then take that information and apply that to the downstream lineage view. So on this downstream tab, what we're looking at is each of these boxes represents a pipeline that's being monitored by Databand. These don't all have to be the same source system. These could, this could be an Airflow DAG, this could be a Spark job, this could be a Azure Data Factory pipeline. But what we're doing is we're taking that information about the data sets that are impacted, and we're tracing that impact out to see what downstream might be affected. So I can click any object in our graph here, and it will highlight the other objects in the graph that are impacted. So for example, if I, let's see, I don't have these labeled. I guess I didn't change the label on these, but basically we've got North America, Europe, and Asia sales are 3 distinct outputs. And so if I pick one of these, it looks like I've picked the North American one. I can see there's no impact on my Asia pipeline. There's no impact on my Europe pipeline, but there's a big impact on my North America pipeline. I've got every single object highlighted. And then you'll notice there's even this extra tier beyond that that has other items highlighted. And what this is telling us is that this data set is needed as an input of this pipeline. And then this pipeline has its own outputs that are then needed by subsequent pipelines. So this could be a pretty big, dependency graph. In our case, it's 3 levels, but this could be much larger in a true production scenario.
Wow.
Yeah, so we'll jump back over real quick and talk about, so that's pipeline failures. Our second most popular alert by far is going to be pipeline duration alerting. So this is where we are wanting to alert on pipelines that are either finishing too quickly, or more commonly, they're getting hung up and they're running forever and it's slowing things down. So what you'll notice in here is that even though you can set this alert at the level of an entire source or an entire project or multiple pipelines, I'm going to pick a single pipeline here because it can illustrate the anomaly detection here at the bottom. So you'll see at the bottom, I've got this graph that's got my last 10 runs. I can see those durations. And so from here, I can start to set those basic comparison operators, like tell me if this run takes longer than 10 minutes, tell me if it finishes faster than 1 minute, tell me if it's between something. But the most common way we see people doing this is they're setting anomaly alerts at the source level. And that's basically telling Databand, look at all my pipelines, look at the history of all those pipelines as they move from one day to the next, and tell me if any pipeline on any given run has a duration that we would consider anomalous. So this graph at the bottom will give an illustration of what that anomaly detection looks like. So remember earlier I said the defaults for anomaly detection are going to be 10 runs of look back and a medium sensitivity. And what it's going to tell me at the bottom is that over the last 30 runs, hypothetically, if this alert was in place, I would have gotten 4 anomaly alerts. And so I might look at that and think, well, that's reasonable. Like these look pretty good to me. But in other cases, you might determine there's not enough alerts, or even worst case scenario, alerts are too noisy, because when you have noisy alerts, that's when people start to ignore those. So what I can do from there is I can start to tweak these parameters, and it looks like I don't even have 20 runs of this pipeline, but I'll toy with the sensitivity a bit, take it to one of the extremes, and you'll see that this forecast of the number of alerts is going to jump up or down depending on that sensitivity. And again, this is typically we see people enabling this at the source level, so you don't have to do this pipeline by pipeline.
It also makes sense to use this anomaly detection, right? Because very often you don't really know what is the number.
Yeah, exactly. It takes out the guesswork of having to say, well, I know this pipeline usually runs from this to this, so we'll say, tell me if it's greater than this or something like that. But yeah, the anomaly detection is always relative to that particular metric, right? So over time, we're expecting data is going to grow, and we don't want to have to constantly recalibrate that number as the number of records increases, which makes it run longer. it'll naturally evolve with that.
Yeah.
And the way that this looks,
I just want to point out one thing that you said. I think that that is very important, because false positives in alarms, then people start to ignore them, and then the actual alarms are not getting looked at. So it's a huge issue. It has been a huge issue for a long time, for yeah, in many projects. So that's a really cool solution. I like that a lot.
yeah. And just to show here how this looks in the alert details. So you'll notice like the context of the screen will change a bit depending on the type of alert you're looking at. In this case, it's a run duration alert. So we get this graph of the last 15 runs. We see the point that triggered this anomaly, and you can kind of get a sense of, like what the surrounding values are. You can jump to any of those previous runs if you wanted to. And of course, we've still got like the impact analysis, no error message because this didn't actually fail. So that's what that one looks like. So continuing to move forward, we talked about the ability to do things like schema changes. So, and by the way, I did just see another person that had registered, and I've approved you, so I don't have anybody in the queue right now. So I'll keep taking a look every few minutes. But so we talked about the ability to do things like data set logging, whether that's automated data set logging from tools that provide access to that info, or more manual logging, such as using our SDK to wrap around data frame objects. One of the common alerts that we'll see with that is going to be schema changes. And if you'll remember earlier, I talked about how you don't have to do any babysitting of your schemas in Databand. You don't have to keep a definition of each individual data set, but rather for any given run of a data set, we look at the last run before that and see if anything changed. So I've got several examples of schema changes here. I'll click into one. You'll notice we've now got a new tab here called Schema Changes, and it's actually going to tell me what those schema changes were. So in our case, I've got 3 data sets that were impacted. It looks like 1 column was added to each one. And this makes sense because these data sets lead one into the next. So if something's missed up front, it's probably going to be missing at the end of the chain as well. But I can drill into this and I can see exactly what that schema change was. So I know 1 column was added. It was a column called incident address, and it was a data type object. So again, this will apply to columns added, columns removed, or data types change. So the next run comes around. Let's say this incident address still exists, but now it's been changed from object to we'll say string, even though I think object is a string basically in Python. It would tell me that. It would say like used to be object, now it's string, or used to be string, now it's integer, whatever it may be. And this is really important when you're dealing with third-party data sources, or even sometimes when we're working with these large enterprises that have these massive data teams spread across the entire world. Those sometimes can even feel like third-party data sources. You don't necessarily get that attention of getting a heads up that, hey, we're changing this data set, so just beware downstream. So this can give visibility on that, and ideally, if you've got something hard-coded in your script, you can accommodate these new columns if you're not already. On the subject of alerting in code-based operations, like with Python or PySpark or Scala, we have a tool that you can use, which is our custom metric logger. So Databand, as you saw earlier, everything comes through to Databand. All the metadata we collect comes through in the form of a metric. So if I come in here to this relatively small pipeline, you'll see I've got 535 metrics. This is kind of a high number because I've got column statistics across multiple data sets. So each one of those calculations, like the min, the max, the average, each of those is its own metric. So this number can get pretty big. But sometimes we have, or the customer will have cases where they want to monitor something that we don't capture out of the box. Well, we have this metric logging function that can be used to solve that need. And it's really just a single line of code. So I'm looking in Databricks now, and I have this example where the data we've been working with so far is public data from the city of New York. We're looking at closed service requests. And so I might have a team that's, let's just say imaginary team is assigned to the borough of Queens. And they want to know on any given pipeline run, how many of these closed requests belong to the borough of Queens. To capture that in Databand as part of the execution of this pipeline, it's really just adding a single line of code. We say log metric. We give this metric a name, so closed requests in Queens, and we tell it what the calculation is that should be logged as that metric value. So here I've just applied a filter on this data frame that says borough equals Queens. So now when this pipeline runs, like I've got some job that's running this Spark notebook, if I come to my metrics tab, here's my metric that I logged. And I can now see this over time. I can track this over time. So if this is some business KPI, you can treat this just like any other metric we've looked at today. You can enable comparison operator alerts. You can enable anomaly alerts. Whatever it is you need to do, you can use metrics for custom metrics for that. So we've seen some interesting applications of that. The most common one that I see is when people are moving data from, say, like a raw layer to a staging layer, and they've got transformations in between. They want to make sure that no records got dropped or added along the way. So they might have a metric that says raw count minus staging count is the calculation, and they'll set up an alert that says, tell me if this ever does not equal 0. I've seen other cases where people have logged like actual lists of values. So they like loop through files. They start with an empty list, loop through files, and they add bad files to this list, and then they log that list as a metric to Databand. So you can get creative with this, but I mean, you can see that it's pretty extensible to solving most business KPI type needs, I think. And then lastly, we'll talk about, and by the way, these examples I have here in Spark, I don't know if there's a way for us to share this with the attendees after this, but I can share this notebook as an HTML file, and people can view this even if they don't have Databricks, and it'll give a lot of insight into what SDK integrations look like. But lastly, we'll just talk about DBT real quick and DBT tests. So I don't know how many DBT users we have on the call today, but DBT is one of those open source tools which is growing very quickly. It's great for simplifying the data engineering process, and it's really helpful with things like tests. We've seen it start to replace some of the older open source solutions like Great Expectations or Amazon's DQ. But anytime you're logging these DBT jobs, you're going to want to be aware of any failures that happen with your tests. So if you'll see here on our graph, we have our DBT cloud job that has been logged. I can see each of my steps in this DBT job. So I've got my DBT run, which is going to give me this nice graph of the lineage of this pipeline. I can click through these and I can see what the SQL was that was used for each of these, which is really helpful, especially if you've got the typical analysts, like data analysts or business analysts. They might sometimes be curious when they're working with the report to know what's the logic that's actually being used to populate this table. And this is how they would see that. And then similarly, we have the same concept with tests. So what I can see with tests would be, any test you define as part of your YAML file in your project will come through as its own object. This object's going to have two metrics. It's going to have one, which is tell me if it's successful or failed, and then number two is tell me how many failures there were. So, for example, if I click over to my metrics tab here and look at my DBT tests, I can see that I have 3 failed tests, and I can identify those here. We had 2 that had 1 error each, and 1 that had 72 errors. And so with DBT tests, if I wanted to, I could enable alerting on a specific DBT test, like straight from the metric screen. But more commonly, you want to know anytime any of these tests fail. And so to do that, we do have a very simple way of setting up DBT tests at the project or the source level. So what I could do here is I can point to my entire Airflow cluster, and if that Airflow cluster has any DAGs at all that are logging DBT jobs, then I can get visibility on those failures. And what that looks like is, if I come in here, you'll see that the context of this screen changes a bit again. So now I've got all this info over here about the column, the tasks, the data set. I can see what the inputs were, and I can get the SQL. And this SQL, I think, just from my limited time working with DBT, is very helpful, especially to people who aren't the actual engineers themselves, because when it comes to tests, especially, you're not necessarily, like, some of these tests are out of the box, and you might not always know what the logic is that DBT is using to conduct these tests. So Databand's extracting this from the run results file that gets created. And so now, DBT will tell you, hey, you had some test failures and this is how many you had, but it doesn't tell you what those failures were. So Databand's going to enable you to, sorry, I clicked back. Databand's going to enable you to quickly see that SQL. I can copy that SQL, and now I can jump straight over to Snowflake, and I can execute that, and I can see this information here. And that one produced no results. I might need to change it a bit, but basically, to get it out of like the test format, I'll say, select everything from services, close request, where open data channel type is not that. And I think this table's been truncated since this error, or since this test happened. But basically, the takeaway here is we make it much easier to get from the point of looking at a test failure to seeing what the actual values are in your warehouse. Because again, DBT doesn't always do a great job of that. So this just gives an extra layer of observability on top of DBT. We do support DBT Cloud as well as DBT Core. In either case, we have the option of a simple Python function that can be used to log jobs, and you'll see an example of that here. So basically, collect the info from my DBT Cloud job. This is my account ID. This is my token. This is the job run ID, and I've got most of this parameterized, and Airflow is feeding these in. But we also have the concept of a DBT monitor for DBT Cloud specifically, which I don't have enabled in this environment. But the idea there would be, if you're a DBT Cloud customer, you can point to your account, provide the credentials, and a Databand will pull your DBT Cloud account every few seconds and pull back any jobs that are running on DBT and show them as their own pipeline here on the Databand UI. So with that, I think we've hit the examples that we wanted to show. And so I'll turn it back over to Ryan or Andreas, or we can get to some questions now, I guess, if there's any that are outstanding.
Yeah, thanks, Eric. That was awesome presentation of the features. The question, what was it just now? I was muted and I already forgot.
See, do we have any data validation features? So yeah, that depends on what you're looking to validate. Some of this, if you're talking about column level validations, that could be something that you accomplish with column level statistics. So you saw earlier where we were logging data sets, and we want to make sure those values are in line. We have the ability to come over here and do a data quality alert, which will allow us to do some of these things in bulk. So if I pick one of my data sources here, I'll see all the columns that I have. I can pick a few of these columns, and then I can pick my data quality rules. I can add that rule. I can add multiple rules to each group of columns, and then I can add additional groups of columns. So this is a way that you can knock out a lot of the data quality type alerting when you are logging data sets, and specifically logging custom or column statistics. Other ways you might be looking to validate, that can mean a lot of different things, but we've got alerting around record counts. So, validating that, your data set is not empty, or that the data set's not huge compared to historical baselines, like maybe the same file got dropped multiple times and you didn't pick up on it. We've got the schema change alerts, which will tell us that our schema is conforming to what we've expected based on previous runs. And then, of course, we have the custom metrics that we just talked about a minute ago, where if there's something we're not capturing out of the box, you can pretty much write any logic imaginable and log that as a metric to Databand. So you could have a very specific, like maybe you're working with US data and you want to know some metric about a specific city and a specific state. And so you can write that logic and get that down to a really, really fine grain, if you wanted to do that.
Yeah, by the way, that code, not that code, but how to do this, I did this when I created the video where I tried out DataBand, and I have this on my GitHub. In the link of that video, or in the description of that video, is a link to my GitHub, and there I have for custom metrics and so on, and for dataset logger. I have the source code for this for Python, how to do this.
Yeah, and what you'll notice if you wanted to test this on your own, like I said, we'll leave this environment up. So if you wanted to test this, like maybe you don't have Airflow or Spark or anything readily available, but say you want to test our basic Python integration, you can simply come over here and generate a personal access token, and then you can write code that can log to Databand. And I don't know if I have an example of that readily available. Well, I mean, you'll see the example here. You'll see some of the examples of like the calls we might make. So for instance, DB&D tracking, this is what gives us the concept of like a tracking context. So anything contained within this code represents a pipeline in Databand, even though it's just a Python script, right? We could give it a pipeline name, a run name, a project name, and then we just tell it what code should be considered the pipeline. We have our task decorator, which is how you get to the point of tagging your functions and having them represented as if they were steps in a DAG. So what you're looking at here on this screen, this custom metric logging pipeline, this is this Spark job here. So we went from this Spark code here, this Python code here, to having it look and feel like an actual pipeline. And I can now go through this and see what the steps were. I can alert on the overall success or failure or duration of the overall script, but I can also do it at a per function level. Then we talked about the data set logger, which, I mean, there's some applications of that in here where you can see that we logged data sets using the data set op logger, and then of course custom metrics. So these are all things that you can validate pretty easily in, you know, something like a Jupyter notebook or just a Python file you want to run locally. You know, just create some dummy data, use some of these functions, wrap around, create some custom metrics, and you'll see that as that script is running, it'll show up here on the pipelines page as if it were a pipeline. And it will be in near real time. It's not a case where the entire job has to finish and then it transmits over. You'll see the actual status and progress of that script as it's running on your machine or wherever it's running.
Jesse had another question here. Insightful presentation. I think so too. Are there any best practice recommendations for different use cases, including LLM ops? Do you have something like that?
I don't know offhand of any customers using this in like an LLM scenario. I would say that data science or ML teams in general are groups that could benefit from this, especially our SDK integrations like you see here, because those workloads are often heavily code based. So Spark is very often the tool of choice for those. You've got you know, your numerous open source libraries where you're training your models and whatnot. And Databand comes into the picture there because number one, we have the data set logger, which we see some ML users use to wrap around, like say their training data set to make sure that there aren't any crazy outliers, to make sure they're not basing their model on bad data. We've got the custom metric logger, which we see people using to do things like logging the scores of their models and alerting on those. So that'll allow you to do a lot more like set it and forget it type things and let your model train as it normally would on a schedule and only get alerted if there's, you know, some violation of some rule that you've established. We do have integration with ML flow specifically, so you can use Databand can essentially replace ML flow's metrics repository. We've got similar functionality with tools like Great Expectations, but ML flow is the one probably most closely associated with like LLM type stuff. I mean, I've never done any LLM development, so I'm sure it's pretty intense, but we do have some ML use cases. We do. So there is. So Databand has two components. We have the SDK, and then we have our web application. So um, up to a point, our SDK was open source, where you could see like behind or under the hood of all of our integrations. The web application is not available openly to just to test out, because I mean it would essentially be like having access to the paid. Like we don't have a free version yet or a trial version yet. Um, but what we do have is, if you ever wanted to do a POC, we do have free POCs at IBM. So if you've got a use case that you think Databand would solve, we could talk to you. We could help set up that instance, and you could try Databand out for a few weeks with no commitment, no cost. See if it's right for you and get a feel for things. We have two different deployment models. So we have our managed solution, which is Databand completely hosts everything for you, do all the upgrades automatically. You get earlier access to new features since we validate those with our SaaS customers first. And then if you want to go the self-hosted route, we have both a Helm chart and a Docker Compose image. I'll say that I've never actually seen anyone use the Docker Compose image in production. It's usually Helm. So, I mean, we've got customers deployed on pretty much all the major Kubernetes managed providers out there: EKS, AKS, GKE, OpenShift under IBM. So you do have options depending on self-hosted versus SaaS.
I think for many companies that's also very important, right?
Mhm.
From a privacy or data security standpoint.
Sure. Yeah, and about that, like we try to push people towards SaaS just because there's advantages for us, there's advantages for the customer as well. And the main thing that we always point out is, again, you're never sending your actual data to Databand. So if you're concerned about like egress costs of sending, gigabytes of data to us, that's not happening. If you're concerned about PII data getting sent to Databand, that's not happening. It's just execution metadata, and in some cases, when you get to like code-based activities like we're looking at here, you would have column aggregates. And if there does happen to be some PII value that's part of that some data set, you can of course exclude that from being part of those statistic calculations. Like I would say the average pipeline run that gets sent to Databand, the total payload altogether is maybe a few megabytes, if even that. So there's not a whole lot of metadata being sent at all. I mean, there's a lot of metadata. It's just not very big in terms of like physical size.
Yeah. No, I mean, of course, if it's something as a service that's always easy to use, easy to set up, and saves a lot of time for companies.
Mm-hmm.
Yeah. Eric, you want to show something else, or should we like bring in Ryan again?
Yeah, I think we covered all the examples we had hoped to cover. We talked about failures, duration issues, schema changes, just going through our list, DBT alerts, custom metrics. Yeah, we hit all the high points. And yeah, anyone who's in that environment, like we said, I'll leave that up for maybe like a week or so, maybe the end of next week. And if you wanted to, like test out some Python code just to get a feel for it, like set some alerts, feel free to do that. Or we've got all of our demo pipelines running in this environment, and I've got failures set up to happen throughout the day. So these pipelines run every hour, and pretty much every alert type we have in Databand has some forced alert happening throughout the day. So you should see plenty of examples of pretty much every alert type.
Cool. All right. Thanks, Eric, again for that awesome hands-on. A lot of people like it. Yeah, the link is in the description of the video to try this out. Ryan, you want to say something? Oh, I guess you're muted. I can't hear you.
Sorry. Yeah, so I was gonna say too, if anyone wants to have like a more customized demo, you can go to just type in IBM Databand, you'll be brought to Google. You'll be brought to the IBM website and just submit a request demo, and we're happy to do more of a customized demo depending on kind of where you're at in your observability journey. So we're also happy to do that. But yeah, there's lots of videos and content online as well. I know Andreas has a video he's done with Databand. A lot of materials out there. So yeah, reach out to us. Whenever you start to think that maybe observability could be a solution for your organization today.
Yeah. Cool. So then, thanks everybody for being here. Thanks, Ryan. Thanks, Eric.
Yep. Thanks, man.
For that awesome presentation. I'm going to post the links here again in the chat for my video that I've done on Databand and our talk that Ryan and I had. And then, yeah, see you next time.
Awesome. Thanks,
Bye.
man.
Thank you.
Thanks, guys.